So hello everyone, and today I want us to design this tunnel, and we are going to use the subassembly composer as opposed to extruding this tunnel through a line. So if we do using the subassembly composer, then we can import it into C3D, and then we can run it as a corridor model. So like what I have here is a tunnel, so we are going to replicate this into the subassembly composer. So if I open the composer itself, this is the way it looks like, and the first thing is to determine the first point. So the first point will be P1. So from here P1 will be here, because we want to design only this side of the subassembly, and then we can mirror. So let's go back, and now that first point, we're just going to create give it a parameter name, or the point code. Let's call it point code, point code, and it's going to be on this a string, and then we just write point code like that. So we can copy this one and paste it there where we want to have the point code, the code name for that point. The next thing, we want to establish the center point, and the center point is here. So what you want to first of all understand is maybe we can remove these ones, and we can trim that part, and also, so we first of all establish this point, and this point is also the radius of this circle or this arc. So if we do like 3-point circle, so we have the point here. So this is the center point that we want to establish. So just come to the subassembly composer. We don't want it to plot, so we use an auxiliary point like that, and we don't want to have it with a link, and it's going to be from P1. So we need first of all to create a parameter. We call it radius, like that. So let's give it 6, and so we can copy this one, and then distance from P1 will be the radius. So let's see, yeah, this is the point. Now we create another auxiliary point, and this auxiliary point, we also don't want to have it, we don't want to have it with a link, and now it will be from P1, AP1, and then delta y will be radius. So let's see, like that. Now the next thing we want to come here and check is the location of this point here. So the location of this point, we can trim part of this, and we see it has a distance which is twice the radius, so at an angle of 24.3. So we come to the subassembly composer here, and we just create a point. So we now create a point, and that point will be at an angle and distance from AP2, and the reference point can be P1. The angle we put 45, then distance will be radius times 2. Okay, so this is the point, but I think we shouldn't put 45. I think it's not 45. Let's check. It is 24.3. It's 24.3. So now we have the point here. The other thing we also need to check is, let's come to the design here, and we want to get the location of this point, but this point we cannot locate because we don't want to give it a specific length. We want it to be determined by an intersection, and that intersection will be, we will first of all extend this line. Let's extend it to the end here, so at least we have this point here. So let's create this point, and it will be let's come to, it will be an extension of AP1, P2, and the tunnel thickness. So we can add another parameter here. We write tunnel thickness, and maybe we can give it a figure of 0.5, like that. So we want to create another point, but maybe it is not okay. Let's just use a point, although we can also use an auxiliary point, but for us to create a curve, the end point will need to be a point, not an auxiliary point. So it is okay even if we just create a point. So that point will be an extension of the P2 here, so we can copy this one here, and then we also want this to be angle and distance, reference point from point AP1. The reference point can be P1, and we want the angle to be 24.3, if you remember, and this is the radius plus tunnel thickness. Okay, let's see if we have it. I think something is not, this one is I think should be from AP2, not AP1, AP2, like that, because AP1 is this one, so we want it at and as an extension of AP2. So for us to be able to avoid more confusion, we can run an auxiliary link here, and it will run from from AP2 to P3. So we have it here. Now the other thing we need to do is to create another point here, and that point we want it to be at below P, okay, let's delete it, below P1. So we want to have a point here, and that point will be from P1, and the X will be the channel thickness. Okay, and now we have to put it at negative, like that. So we have this point and we have this point. For us to create a curve, we need to have another point which is along the curve. So let's create another auxiliary point here, like that, and that auxiliary point will be from, it will be still at an angle and a distance, but this time okay, this is from PAP2, and the reference point will be P1, and the angle we can even try 10, and then distance will be tunnel thickness plus radius times 2. Yes, so this is the arc point. So let us create a curve that passes through P4, P3 and P3. So we get a curve here, and this curve we are going to use 3 points. So the first point will be P4, the other point will be P3, and the other point will be P3. So we have an arc which moves along that path. Now the other thing that we don't have is an extension of P2, so that if we get a point somewhere here, that point can be intercepted by the extension of this link. So let us add an auxiliary point, because we don't want it to plot when we take it to C3D. So it will be still be, so first of all we check, so it is angle and distance, so we do the same. So angle and distance, but now from AP1, and the reference point will be P1. Now the angle, if I remember correctly, it was 45. Now the distance is the radius, but now we can add anything, an extension, maybe like I can add like 5. Let's see where we are. So let us create a link, auxiliary link here, and that auxiliary link will connect the 3 points. So that tells us that what we are doing now, we have extended this line here. So if we come to this one here, let's see if it is, yes, like that. So what we are doing is we are extending this line, and then we want to intercept to get the point here. So the next thing we want to do is to now create an intersection point, and that intersection point can be created by, let's try 2 links. So the first link will be L1, and the other one will be AL3. Okay, so for us to be able to get that point, maybe we need to extend the first link, which is, yes, no, we have the point here. So this point has now been found. So we just come here and create a link. Forgive my small screen size. So this point P3, P5, so the link, we just connect P3 and P5. Okay, so we have an extension, and we have a curve that moves to this point. So the next thing we need to do is now to have a point which is at this point. But where is this point? It is a distance of the tunnel thickness. So we can come with an auxiliary point, Okay, I think the screen is very small. I'm using a laptop, so maybe issues like that can be so. I want to move this one here like that. Here like that. Oh, and I think we have issues with our display, but so long as it's not a technical issue, we can just. So this is the way we try to zoom. Yes, and also we'll be able to get more space. So we want to create a AP5 where, let me see, this is the last point, the last ring. So yes, this is the point now we want to define, but we want it from, let's now see, it's an angle and distance, but it should start from AP2. So let's start from AP2 and its angle and distance. So what was this again? This was 10 degrees. So if we come here, P1, you remember this is the reference point, the reference line, and then the angle will be 10, and then distance will be radius times 2. Okay, let's see. Yeah, now we have that point here. So we want to join the 3 points, so we bring the curve like that. So we do P1, okay, AP5 and P2. Now we have a curve there. Now let us do the same for the other location of, if we go back to the drawing, for the location of this point, and we know that the location of this point here, if we trim, let's trim, if we trim, see how is the distance of 6 meters, so it is 6 meters from the center, but there is more to that. Maybe for us to be able to properly get that point, we need to locate a point here, and that point is also at the distance of radius from the center, so from AP1. So let's go back here, and from AP2, so we come here, we add an auxiliary point, and that auxiliary point will be from AP1, and the distance will be minus radius. Now let's see here, this is the point, so that this will be the arc with the center at this point. So let us now locate a point here. So we bring a point, and after bringing that point, we have to give it the distance, which I think is radius, times 2. Okay, are we there? I think shouldn't be the x-axis, not the y. So let's have it. Yes, this is the point. Now what we also need to do is to locate another point here, but yes, that we locate another point here, but this time it has to be at an angle, but the distance of r radius multiplied by 2. So we create an auxiliary point here, and that auxiliary point will be at an angle and a distance from AP6. The angle, let's say try 10. Distance will be radius times 2. Where are we? Oh, it should be from AP. Should be from AP6. AP6 reference point. Okay, let's use a reference point of P6. And now the angle we want to, maybe we can just do it negative. Now we have the point here, so it means that this line here is just rotating. So if it rotates at this point, it becomes P6. Now we just want to have the curve which is here. We now come with the start point can be P2, the arc point will be AP7, the end point will be P6. Okay, now you have that arc here. So what else are we remaining with? We remain with the point P6, but now we need to get to the outer side of the tunnel. So we add another point. That point we can just put it at from P6, and then delta x will be the tunnel thickness V. Yes, control V. Yes, this is the point, and now we want to connect. So what can we do? We just extend the AP7, so we add another point, but an auxiliary point. So we come here, and that point, can we, let's see if we just work with the short distance, maybe from AP7, or we just work with the, let's go back, just start from AP6, so it's angle and distance. The reference point will be P6, like that. The angle, I think it was -10, and the distance now will be radius times 2 plus, plus tunnel thickness. So where is that point? Yeah, this is the point. And maybe we can have, we remove the link, then we add another auxiliary link. That auxiliary link will connect AP7 to AP8, like that. So the next thing is just to come here. Now we add a curve, and the curve we use the same method we have used previously. So it will be P6, AP8, the last one will be P7. Oh, didn't we do something wrong? So I think this is P5, so P5, like that. Now you have identified all the hand part. Now the other thing is to create a point here. So just come here, point. Where is the location of that point? At AP2. So we have that point here. Now we create another curve. Let's get the curve. So curve here, like that. And we want to use a general curve. So the center point will be AP6, this one. The start point will be P6, the end point will be P8. Did we do it correctly? P6, P8, AP, not AP6, it is AP1. That's I was thinking this one is the center, but the center is AP1, if you remember. So the next thing is to have another point. So we create another point, and that point will be from AP1, and it is the height, the distance will be radius plus tunnel thickness, like that. So this is the point, and we can connect with another curve. So the curve will be from the arc point. We want general arc, so the center point will be AP1, the start point will be P9, the end point will be P7. Oh no, I think we interchange, so P9. So we have made the most important parts of our tunnel. So maybe if you want, you can, although I don't think it is very important, you can just add an auxiliary link between AP6 and P7, I think, or P6 any. So we have all these kind of connections which will verify if your design is correct. The other one is to just have a link here, and that link will now connect P8 and P9. So P8 and P9, like that, and the last one will be P1 and P4. So bring this one, so it will be P1 and P4. Okay, so what is remaining is we can create another code here. We call it a concrete. This concrete will be a string, and now want to be concrete. Okay, so we want to drag a shape, so that when you go to C3D, then you can see the material inside, and it can help you to create a solid. So we just maybe can write concrete like that, and then just put it there like that. So let us see what we have. So we can code the points. The importance of coding is, if you make a corridor model without the codes, it will be very hard to generate across an AutoCAD usable information. For example, if you want to have some labels here, without the links, without the coding, it will be very hard. So we want to just give them we have a link code. We can create one link code, so sorry, I think should be string. So link code like that. So I want to copy this one, so we can just start one by one here. This one don't want, because we are not going to plot them, so we can copy the point code here like that. The other one is the same point code This one we not need, this one we need. So all the auxiliary links and points, we cannot have a code. So this one will be link code. By now you understand the link is this one, this is the point and this is the shape. So just you have to relate them with this. So do we have this is an auxiliary link, so this one will be point code. Copy like that, link code, copy like that. Let's go to the other one here. No, that one we don't need, this one we need. So we copy, paste, and P6 is a point code. The same we need here a link code like that. So I'm copying and pasting, so it's Ctrl C, Ctrl V. So P7 is a point, so we need a point code. Copy, paste, and the rest do the same. Link code, copy, paste, P9 point code, paste, the same. This is a link code, paste. Then we want this one, link code, and then L9 will be in a link, so we link code like that. So let's see what we have. So now they have been coded, link code, point code, all that. But I want to change this one, so I'll create another parameter here, maybe call it P1, and I want to give it a name, sorry, P1, so write mark point. So we can change, so we can just copy mark point, copy, can we have the same? I think but I think we should have this one as point code, sorry. So let's change like that, so this one becomes a point code, but this is an important point, so we want to label this one as P1, copy like this. But mark point, yes, maybe we can also do the same here, and we want to give it the same code. And the reason I'm doing that is, if you want to label everything that we give the same name, especially points and links, will be labeled, then the drawing will be very messy. So I just want to have 2 points labeled, this point and this point. So I think we have done most of the work. Let's check. I think this one we did not change, so this one should be point code, copy, paste like that. So we also check something we have not done. We have everything. This one we not named, this one okay. So we now save our drawing. You can write tunnel. Okay, so we just come here, we save us in our, I want to save it in our documents, and we have some assemblies somewhere here. So I want to call it tutorial tunnel. Like that, tutorial tunnel. So this drawing is now. So when you come to the C3D, this is the name that you'll see in that subassembly. So we can even add something to just mark it. So come here, we save, and then we close. Now I want us to remove this one, and I want us to remove even that one. Now I have a profile here, and this profile, the profile that we'll be using to model our corridor here is this profile, and it has the name of tunnel. So, and these are some sections I have created. You see they have nothing, so we can even just create a new subassembly or new assembly. So just create assembly, we call it tunnel, we just give the name, then click OK. So we come here, and I think let's delete these ones, and we delete this one too. And now we want to bring a new one, so import some assemblies, and now we have saved it in documents. So this is the one, and we want to have it here, and I think it has come. So we just click it, and then we come here, we want to attach it here, and we can also attach another one here. So I think something is wrong because we did not allocate assigned. So this is only work with only one side. So but we can just go back to the subassembly composer here, and just open this one. So you can see we have the sign is ribbon none. So if you want to be able to flip, we can give it a sign. So this one is right, and let's save. But also we can change to another name, so that we don't run a risk of conflicting with the other one. So this one, we come here, we save again, then we close. So we can come here and import the subassembly, the one that we have created right now is this one. Okay, so you can see we now have it. So what do you want to do? We want to replace. So we want to replace this one, so we replace like this. And now I think maybe we can just delete or even delete all of them, and we can mirror. Can we mirror? Let's see. Yes, now we can mirror and have a symmetrical one. Now supposing we don't want, we haven't set the radius, now we realize we need another radius. So we just come here and go to the assembly properties. The whole of all these is what is called an assembly, that one. So we just go to the assembly properties, and we go to the construction, and we want to change the radius, so let's try 4, and the other one we also try 4, and maybe the tunnel thickness we try 0.25, the other one we try 0.25 right there, and apply. So you realize it becomes smaller. So what else can we do? So I want to make sure that you don't have any corridor here, so we can select it, and I want us to delete it. I think I will delete it. Yes. So let's create a corridor model. So we create corridor, we come here, and let's call it tutorial tunnel. Okay, so we are going to use alignment and profile. So do we have the profile we have, and maybe we can just, do we have it? Yes, but I think it is in a hidden layer, so let us see if we have it, if it has been hidden. Okay, because I suspect it was hidden. Yes, this is now the alignment. You see we have the alignment here, and this is the profile. So let's create the corridor model. So just create corridor. So we have it here, we don't have another one, so we just pick this one. The topo is the same, but do we have another one? No, we don't have. So let's see what you have here. No, we don't have, so go back. So let's use this one. Then let's use this one, the assembly, and I think we are going to go. So here we can change the spacing, maybe you can put 10 meters, and run the curves. We don't have curve because, but we have a curved profile, so we can maybe put them closer, like 5. Spiral, along the spirals we don't have spirals, but we can just leave it. In fact, we can just leave everything as it is, and then along the vertical curves, maybe we can change this one to 5, and the rest, then click OK, and apply the beyond the corridor, and we want to see what we have created. So this is the model, the corridor model. So, but it is hard to appreciate it like this, so I suggest that you create a solid out of it. So we just come here, click the model, then it will take you to extract corridor solids. So it is asking me which part of the corridor, and I only have one part, so I just say all regions, and go next. I think we want just to have it in the drawing so that we can have it dynamic. Dynamic means it will change if we change the profile, and then it will build. So let's extract, and I think we have it. So let us see what we have created, and let's go to the objective viewer. So we have oh, but something happened. That one I can explain what happened, because we extended our corridor even to places where there is no profile. So our profile should be, our corridor should be up to, maybe we just push it yes, because if we look at this alignment, it has exceeded outside of our range. I think so. 494. Okay, so you can see now, you can see here, the reason why we're having that problem is because this is where our profile gets, and this is the extension of the alignment. So when the model reaches here, it doesn't know what to do, so it will just create that error. And maybe, so it's better to go up to 090. So when we have 090 here, so corridor 090 is not there. Yes, let's go to here. Better still, we can just go to the corridor properties, and the parameters, we just end station. So we just specify station. Maybe can we do that? Just write 90 and apply, then we rebuild. Okay. Oh, okay. So let us see if we are okay now. The grid is orange and the other one. So object view. Yes, now you can see we have our channel, and it is having, there was some places maybe we should have changed the frequency of the model. So just go to the corridor and then we go to the edit frequency. So maybe curve increment, you can do 1, here you can do 10. Do you want around spirals? Horizontal geometry? No. I'm just going to offset target. Maybe we don't have. Right. So what do we have? Maybe we can try and see if we have it in the sections. And I noticed the issue is a different one, because maybe our design is not based on the, so let's use go to the properties, and I think the vertical profile is wrong. So I think we should have used the correct one, which is tunnel. So let's rebuild. And these are the issues that you can have at times. So this one was running on the existing ground, but now we have to change, and I think it has changed. So let us see what you have, or you can even look at the design here. Now you can see it is below there. the ground, because this is the OGL and this is the tunnel. So let us see what is happening. Solid. And now let us go to the objective viewer. Yes, now this is correct. So I'm sorry, this is quite a long video, but I think it has done some justice and on how you can design some challenging geometry. So with Subassembly Composer, I can say that you can almost do almost everything in design and in linear projects. So thank you for your time. As usual, do not forget to like, share and subscribe to my channel. Also comment and make this one a good running platform. So thank you for your time and goodbye.